Let's take a look at coefficient of determination, explained and unexplained variation, and prediction intervals. Your coefficient of determination is r squared. That is the notation for it, and that's also a way to calculate it. If your r value is known, just square it. Use your calculator. The explained variation. Basically, you've got a situation where you've got a bunch of points. You've got the mean for the points. You've got your regression equation. For any particular point, well, let me make a point up here, sorry. For this particular point, so that it would line up with this x value. If we use the mean value as an estimate, so that our y value is just the mean, but the actual point is up here, the distance between the mean and the regression equation value is the explained variation. This is how much the value of this y, this point xy, it's how much the y value varies based on the regression equation explaining it. And this distance is going to equal r squared. The remaining distance between the two is unexplained, at least unexplained by the regression equation. It could be explained by other factors, or it could just be based on randomness. So the explained variation is your coefficient of determination written as a percent. The unexplained is, since from here to here is 100% of the distance from y to x bar. So this much is explained, this much is unexplained. So if the total distance is 100%, then the unexplained is going to be 1 minus r squared, written as a percent. So for this particular problem, we have a situation where they're giving us the linear correlation coefficient r. R squared, if we just use our calculator to get 0.465 and square it, we get 0.216. So the coefficient of determination is 0.216 r squared, which means that 21.6% of the variation is explained by the linear correlation, by the correlation line. And that leaves 78.4% explained by other factors. In this problem, they've given us some output from a Minitab, which is similar somewhat to StatCrunch. It is another way of getting the same information. So we have paired data consisting of the weights in pounds of 31 cars and their highway fuel consumption amounts in miles per gallon. So this is their gas mileage. And then along with the paired sample data, Minitab was also given a car weight of 3,500 pounds to be used for predicting the highway fuel consumption amount. So specifically what the highway fuel consumption amount, the gas mileage, would be for a car that weighed 3,500 pounds. Recall that a prediction interval, unlike a confidence interval, has to do with getting a prediction for a specific X value. It's for the Y value. It's an interval for the Y value for a specific X value. Where a confidence interval is going to find our confidence in predicting, say, a mean or standard deviation or proportion. So they're different. The prediction interval is typically going to be larger than a corresponding confidence interval. So if we take a look at the display here, the first thing we see at the top is the regression equation. Notice that the constant up here is here. The slope up here, negative 0.00502, is here. If we're looking for a test statistic or a probability, a p-value, those are here and here. Those match up with the slope, just like the sign on the correlation coefficient is going to match up with the slope. So we're asked for the correlation coefficient R. We're given R squared, and we're given R squared as a percent. So R squared is 64.8%, which would be the same thing as 0.648. If we'll just pull up our calculator, let me get all this out of here. If we'll pull up our calculator, 0.648, and get the square root of that. So the square root is 0.804. So R is going to be the square root of 0.648, which is 0.80, well, 805 if we go 3 decimal places. However, notice when we go back that the slope had a negative sign. So R could be plus or minus the square root. We're going to have to put in the negative. The correlation coefficient is going to be a negative 0.805. Is there sufficient evidence to support a claim of linear correlation? Okay, well, now, as I said, I don't see anywhere where they actually gave us an alpha value to use, but given that the probability here of getting these numbers, if there is no correlation, the probability is 0, I would say that's pretty good reason to think there is a claim of linear correlation. Good enough. Let's take a look at another one, because we're getting to the point now where we're going to have to start calculating everything ourselves. Use the accompanying paired data over here, consisting of registered boats in tens of thousands and manatee fatalities from boat encounters. So if a boat hits a manatee, it has a tendency to get killed. Let X represent the number of registered boats. Now, so they're not counting how many boats have killed manatees. They're trying to see if having more boats is going to result in more fatalities. And let Y represent the corresponding number of manatee deaths. Use the given number of registered boats and the given confidence level to construct a prediction interval estimate of manatee deaths using X equals 87 to represent 870,000 registered votes. Remember, that was in tens of thousands, with a 99% confidence level. Okay, let's see what we got here. If we load this into StatCrunch, then to get my information, just like we've been doing, I'm going to go with stat, regression, simple linear, tell it where the X value is and which one's the Y value. Okay, now, because we're going to look at a prediction interval, I have to put in the X value that I want to get a prediction for. So that, in this case, is 87. The prediction level, 99% confidence level. And I want to go ahead and pull up the graph so you can see kind of what the confidence interval is meaning. The graph on the second page, this is our regression line. And I can actually get the regression line just from putting my cursor on top of it. This is the 99% upper prediction, and this is the 99% lower prediction. So we expect 99% of the numbers of manatees killed for a particular X to fall in between these. Since we're looking at 87, which would be about here, our prediction interval is going to be from here to here. So let's go back to the other page. I'm going to open this up a little bit so we can see more of what's going on. This has got all kinds of information. Here's our regression equation up here, our sample size. This is R squared. The t-stat and p-value for the slope are going to be the same as the t-stat and p-value for R. Our prediction interval for X equal to 87 at 99% is right here. So our lower prediction level is going to be 44.352, 3 decimal places. Our upper is going to be 101.412. Fantastic. Let's take a look at one more. In this problem, listed below are the altitudes in thousands of feet and outside air temperatures in Fahrenheit degrees recorded during a flight. Find the A, explained variation, B, unexplained variation, and C, indicated prediction interval. There is sufficient evidence to support a claim of linear correlation, so it is reasonable to use the regression equation when making predictions. So they're telling us that. For the prediction interval, use a 95% confidence level with the altitude of 6,327 feet. Now, this is a huge number compared to these, but these are listed in thousands of feet. So we're going to use this as our X value with a 95% confidence level. Let's go ahead and load this into StatCrunch. So let's go with regression. Simple linear. Give it the X, give it the Y. 6.327 feet is going to be the X that we want to get a prediction level for, a prediction interval at a 95% confidence level. Good. Compute. Recall that to find our explained variation, the explained variation is going to be based off of the coefficient of determination, r squared. We see up here that r squared is 0.96399, so 0.964 basically. The actual amount of explained variation is going to be found under this column right here. The explained variation is going to be the 10,104.56. The unexplained variation is the error directly below that, and this says round to 5 decimal places, which is what it's got. So I'm glad it doesn't want more than that. The total amount that they expect would be the 10,482, which is the sum of these two. And now the indicated prediction interval is over here. Here. So 4 decimal places, we're going to put 20.3673688. This is in degrees Fahrenheit, and 72.5730. Now that is a heck of a lot of variation. They're saying the temperature should be somewhere between 20 degrees and 72 degrees. So that's not a real refined prediction. So let's look at one more of these. The table below lists weights in carats and prices in dollars of randomly selected diamonds. Find the explained variation, the unexplained variation, and the indicated prediction interval. There is sufficient evidence to support a claim of a linear correlation, so it is reasonable to use the regression equation when making predictions. For the prediction interval, use a 95% confidence level with a diamond that weighs 0.8 carats. So let's load this in. Put it into our regression. Select X, select Y. Our prediction value is going to be 0.8 at a 95% confidence level. Compute. So again, pulling this out. To get your variation, unexplained and explained, look under SS. The explained is going to be the top number, 16178944. The unexplained is going to be the next number down, 1118584. And our prediction interval is going to be listed right down here under PI. So nearest whole number, 2034 to 5434. And that's where you find them in StatCrunch.